Gather your supplies. Proteins need to be kept on ice. Always wear your gloves and goggles. Some reagents need to be kept in the hood at all times. First, gather your samples. Take your samples to the hood to add a solution of SDS, loading dye, and beta-mercaptoethanol. Carefully pipette the preset amount of SDS solution into each sample tube. Then, discard the pipette tip and repeat for all sample tubes. Put all samples in a heat block at 95 degrees. Next, prepare the buffer for the gel electrophoresis apparatus with 100 milliliters of stock solution and 900 milliliters of distilled water. Fill the graduated cylinder to the mark. Cover the graduated cylinder with parafilm and invert to mix the buffer solution. Next, gather the components for your gel electrophoresis apparatus. The gels come pre-packaged. When you remove the gel from the package, carefully check for flaws. Carefully remove the comb from the top of the gel, ensuring that you don't damage the wells. Inspect the gel for any damage or imperfections. Next, remove the sealant tape off of the bottom of the gel. Load the gel into the holder, ensuring a tight seal against the gaskets. Load another gel or the backing plate to the other side of the holder. Next, place the holder into the apparatus. Fill the holder with buffer first. Fill it up to the mark. Take the holder out and ensure that it does not leak. Next, fill the rest of the apparatus to the mark. Remove your samples from the heat block. Carefully load 30 microliters of each sample into the appropriate well of the gel. This is a difficult technique and takes some practice. Do it slowly and ensure that you do not contaminate other wells. Generally, the first well will contain a molecular weight ladder to help you analyze your samples. Cover the gel electrophoresis unit and turn on the power supply. The gel will run for approximately 45 minutes. As it runs, you will be able to see the blue bands of loading dye move down the gel. Turn off the electrophoresis power supply when the bands are a few millimeters from the bottom of the gel. Carefully remove the gel from the electrophoresis unit. And open up the case with the provided tool. Transfer the gel to a Tupperware and cover it with blue Kamasi blue stain. Put it on an agitator and leave for at least an hour, then drain off the excess stain. Next, cover it with D-Stain 1 solution. You can put a Kim wipe in and use the capillary action to help absorb some of the blue stain. Put this back on the agitator for at least another hour. Then drain off the D-Stain 1 and fill with D-Stain 2 solution and a fresh Kim wipe. Put back on the agitator overnight, then drain off the D-Stain 2. Remove the gel from the Tupperware and place it on a glass support so you can see the bands. Photograph the gel for further analysis. Based on your photograph, you will be able to further analyze your SDS PAGE gel. SDS is a surfactant which disrupts all non-covalent bonds in the protein and binds at a uniform rate to the polypeptide chain. Beta-mercaptoethanol is a reducing agent which reduces all disulfide bonds in the proteins, potentially breaking apart quaternary structure. This means that the relative mobility of each protein band will be roughly proportional to its molecular weight and will be uninfluenced by its charge. In the leftmost lane, the molecular weight ladder can be used to approximate the molecular weight of each protein. Information about the molecular weight of each protein in the ladder is available from the manufacturer. In the third lane over, you can see a lane with multiple different bands, indicating a protein with quaternary structure or an impure mix of proteins. In most of the lanes on the right-hand side of the gel, you can see a single small band which indicates a pure protein sample. Sometimes, precast gels suffer from warping in the outside lanes, as can be seen in the molecular weight lane of this gel. This can affect the accuracy and reliability of your relative mobility curve.